So I hope you remember the things that we discussed in our last session about CIDRs and security groups, and we were able to understand a few things about subnets. So let's dig deep into this and let's learn about subnets. And when we try and imagine VPCs and availability zones and subnets as a part of the availability zones, I want you to always have a picture in mind that you are the one who is designing the VPC, and there are availability zones within which you create your subnets. So imagine this VPC to be the piece of land where the house is of 1200 square feet, which acts as an availability zone, and inside which you have different rooms like your subnets. So we have the bathroom, the kitchen, the bedroom. You can think of these as subnets. So there can be many rooms in the apartment, but the only thing is that you don't create the apartments. Just like you don't create the availability zones. The only thing you can create is VPC and subnets inside the availability zones or local zones. And that's how we try and imagine the VPC to be a complete set of private cloud resources that are going to give me an isolated environment to host my services and give me enough control over how I want things to be customized. So now that we have imagined what and how the subnet is going to be in our VPC, let's understand the concept with respect to AWS. So here Amazon VPC actually supports both IPv4 and IPv6 addressing. But for these sessions, we will focus on IPv4 only, as you might be already aware of. And the CIDR block size quota is also kept different for both of them. Okay, remember this point very carefully. And one more point that we have here is a bit tricky, but you must remember this. So by default, all VPCs and subnets must have IPv4 CIDR blocks. Then what about IPv6 then? So optionally we can associate IPv6 CIDR blocks with our VPC. So by default, all VPCs and subnets are IPv4. So remember this point very carefully. Okay, so by default, all VPCs and subnets must have IPv4 CIDR blocks, and you can additionally or optionally associate an IPv6 CIDR block with your VPC. And to have an IPv4 subnet, we must specify an IPv4 CIDR block, and its allowed block size is between /16 net mask and /28 net mask. So subnet mask and net masks are interchangeable. Don't think too much into this. Okay, so you already know now like what is actually these terms when I say like /16 or /28. So if you don't know this and if you still have some confusions, then you can go and watch the part 2, and once you have watched that, please come back here and you can continue from here and watch this session, so you'll get a better understanding of what I'm trying to say here. Okay, and to create these blocks, there is an RFC standard, and once you assign one of the CIDR blocks, that becomes your primary, and after which you can associate secondary CIDR blocks after creating a VPC. Okay. And to create these blocks, there is an RFC standard which tells which range of private IPs are recommended. So you can check them out to know more about assigning private IP ranges. So it's your RFC 1918, that is for address allocations for private internets. So what is RFC? Yes, that's a task for today. So comment below what is the full form of RFC, and I'll put a heart on every right answer. Okay, so comment below what is an RFC. Why am I telling RFC 1918? That is for address allocation for private internets. I want the full form for RFC. So next, if we check the chart here, if the private IP range is like, so if your IP is ranging from 10.0.0.0 to 10.255.255.255, your VPC must be /16 or smaller. So for example, it can be like 10.0.0/16. And if it ranges from 172.16.0.0 to 31.250.255, it must be smaller than or /16 or smaller than that. Okay, so you can have it like 172.31.0.0/16. And if it ranges from 192.168.0.0 till like 192.168.258.255, then it can be smaller than that as well. So it can be smaller than /16 as well. So it is like 192.168.0.0/20. And you can create a VPC with a publicly routable CIDR block that falls outside of the private IP ranges. So don't worry about that. So just to reiterate on this, the CIDR of the IPv4 address range that is created while creating the VPC is called the primary CIDR. that is 10.0.0/16. So that is basically your primary CIDR. And you must remember that VPC spans across all availability zones, and you can create one or more subnets in each of the availability zone. And when you create a subnet, you specify the CIDR block for the subnet, which is basically a subset of the VPC CIDR block. Okay, so you take the VPC CIDR block and you take the subset of that and create a subnet. Okay, subset, subnet. Okay, remember that. So subnet is a subset of the CIDR block. So as I've already told you twice or thrice now, each subnet must reside within one availability zone. And speaking of subnets, it's not fair for us to not speak about the types of subnets. So let's check them out. So the first one is the public subnet. So the general definition states that if a subnet's traffic is routed to an internet gateway, the subnet is known as a public subnet. Okay, so if a subnet's traffic is routed to an internet gateway, then that subnet is known to be the public subnet. And if you want your instance over public subnet to talk to the internet over the internet gateway, you should either have a public IPv4 address or an IPv4 elastic IP. So this is the elastic IP that we are having right now. Okay, so the second one that we have here is the private subnet, the secure one. So if a subnet does not have a route to the internet gateway, the subnet is known as a private subnet, and the target is always set to local. And the third one that we have here is VPN only subnet. So if the subnet does not have any routing provisions through the internet gateway, instead has a route to a virtual private gateway for a site-to-site VPN connection, the subnet is known as a VPN only subnet. So with this, what you can do is you can enable access to your remote network from your VPC by creating an AWS site-to-site VPN, that is the site-to-site VPN connection, and configuring routing to pass traffic through that connection, like the way we use a VPN. So I hope this was clear. Let's move on. So now let's check some of the key points for subnets. So these are very important. So please listen to them very carefully. So if you have a single subnet in your VPC, then the CIDR block of the subnet can be the same as that of the CIDR block of the VPC. So if it is only one subnet, then it can be same as the CIDR block for the VPC. For multiple subnets, you have to use the subset of the CIDR that you have for the VPC. Okay, so as I've already told you multiple times now, for multiple subnets, you can have or you can make use of the subsets of the CIDR that you have. And the allowed block size is between /28 and /16 net mask. And if you create more than one subnet in the VPC, a CIDR block of that subnet should not overlap. You cannot have that overlapping. Okay, so forget about that. And there is a site below that I have mentioned that you can use to get ideas of how you can design subnets. In this site, it will show you how you can divide your VPC CIDR block into number of subnets that you want. So if we see the example here, for us that we have like 10.0.0/24. So let's suppose this is our CIDR block for the VPC, which is targeted to have 256 IP addresses. So we can divide this into two parts. So the first block that we have here is 0.0.0/25. Okay, so that will range from 0.0.0 hyphen or to 127 IP address range. So that will be the CIDR block 1. So the next IP block will be starting from 128 to 255. Okay, so that will be our block 2. So you can divide this into two parts by using this one. Okay, so let's suppose I had to divide that into 4 parts. Then what will I do? Then each one will be having 64 IPs. Okay, so 64 means, so as 2 to the power of 6 is 64, then what will be the block then? So you have to subtract 32 minus 6. So 32 minus 6 is 26. Okay, so it will start from 0.0.0 to 63, then from 64 it will start again to 127, then from 128 it will start to 191, then from 192 it will go to 255. Okay, so in that way. So let's suppose I have /24, then I can divide it that way, and if suppose I have /26, then it can be for 4 parts as well. Okay, so you might ask me 256 IP addresses, I got that, but you might ask me, are you sure all of these IPs can be used? So I would say that, yeah, you might be correct on this one. Not all of these IPs can be used. So let's see what are the pointers in this context. So what AWS tells us is that the first 4 IP addresses and the last IP address in each subnet CIDR block are not available for you to use and cannot be assigned to an instance. Okay, so remember this very carefully. First 4 IP addresses and the last IP. Okay, as you can see in the diagram as well. So these are the first 4 IP addresses and this is the last one. Okay, so this is the CIDR block. Okay, /24 CIDR block. So I'm not able to use it. So this is the one, that the 4 IPs that I have, and the last one I will not be able to assign it to any instance. Okay, so the first one is assigned or reserved for the network address. The second one is reserved by AWS for the VPC router. The third one is reserved by AWS for DNS servers. So the IP address of the DNS server is the base of the VPC network range plus 2. So what did you understand from this? So what exactly it means is that the base is at 10.0.0.0, then the DNS server will be plus 2. So it will be 10.0.0.2. Okay, so whenever you have the base, just add plus 2 to that and you will get the DNS server address. So the last one, as AWS does not support broadcast in the VPC, therefore we reserve this address for the networking broadcast. Okay, so now I would just want to reiterate on this one once again. So the first 4 IPs and the last one is reserved. You cannot use it or you cannot assign it to any other instances. And you must remember that very carefully while designing your CIDR blocks. Now let's move on to some of the rules for applying CIDR. So the below example is going to show us the difference between what you may expect when you have created your VPC with a single CIDR block and the VPC with 2 CIDR blocks. Okay, so the first one, as you see here, we have one CIDR block. Okay, so that is 10.0.0.0/16 with 2 subnets, 10.0.0/17, and the second one is 128.0/17. And when you associate a CIDR block with your VPC, in order to enable routing within the VPC, a route is automatically added to the VPC route tables. So you don't have to worry about that. And the routing table is shown below here. As the private subnet, the destination will be the CIDR block itself, that is 10.0.0/16, and the target will be local. So here I am actually not sure if you know what target local means, but when the target is local, remember this point very carefully, it points to the same VPC. Okay, local means it points to the same VPC. And don't worry about this, we will be discussing this in the routing tables part as well. So for now, just remember this. And here, once we have the primary CIDR set, we can also associate a secondary CIDR, which is created here, as you can see, as the second portion that we have. So that is a secondary CIDR, that is 10.2.0.0/16. And with that, we have created a third subnet using the subset of that from the secondary CIDR that we have. And the routing table is shown here as well. So the destination will be the CIDR block, that is 10.0.0/16, that points to the target as local. And for the secondary CIDR as well, we have 10.2.0.0/16, and that will be also pointed to the local. Okay, so any direction, any instances that are pointing towards this or trying to use this will have to go through the main route table that we have, and it has to pass through the CIDR block itself. Okay, and let's check the rules for adding CIDR blocks to the VPC. So the first point that is very important for us, so I think we have already discussed this. So the allowed block size is between /28 and /16 net mask. And the second point that we have here is the CIDR block must not overlap with any existing CIDR block that's associated with the VPC. And remember one thing, you cannot increase or decrease the size of an existing CIDR block. So please be careful when creating one. And you have a quota on the number of CIDR blocks you can associate with a VPC and the number of routes you can add to a route table. And CIDR blocks must not be the same or larger than a destination CIDR range in the route table or in a route in any of the VPC route tables, because of basic common sense. You cannot fit a 17-inch laptop in a 15-inch case, isn't it? So you must remember that the CIDR block must not be the same or larger than a destination CIDR range in a route in any of the VPC route tables. Okay, and when you add or remove a CIDR block, it can go through various stages, right from associating to associated to disassociating to disassociated to failing and then failed. And if it is ready, the CIDR block is ready for you to use when it's in the associated state. Okay, so remember this very carefully. Associating, associated, disassociating, disassociated, failing and failed. And if it is ready, then it has to be in the associated state. So it has to be associated, isn't it? Yes. Now let's see one of the two most important topics that we have. So subnet routing. So as you know this already, let me put this across once again. When you associate a CIDR block with your VPC, in order to enable routing within the VPC, a route is automatically added to the VPC route tables. And each of the subnets we create must be associated with the routing table. And the good part is that every subnet that you create is automatically associated with the main route table for the VPC. And here you can see this is a very important example, or a very interesting example here, that of the VPC only gateway with the custom route table that we have. So any traffic destined for a target within the VPC, that is so 10.0.0/16 is covered by the local route, and therefore it is routed within the VPC. And all other traffic from the subnet uses the VPN only gateway with site-to-site VPN connection. And we will learn more about this in the routing table concepts as well, so don't worry about that. And for the security point of view, AWS provides two features for increased security in your VPC. So one is with the security groups, which we are already aware of, and with network ACLs, or what we call as network access control list. So the way we are trying to keep it secure is that security groups actually control inbound and outbound traffic for your instances, and network ACLs control inbound and outbound traffic for your subnets. Okay, so one is for the instances you have and the other one is for your subnets itself. And the good thing is that every subnet that you create is automatically associated with the VPC's default network ACL. And to ensure you have the audit in place, you can also create flow logs, or the VPC flow logs, from your VPC or subnet to capture the traffic, or an individual network interface as well. And that can be published to CloudWatch logs or AWS S3. So that actually makes it very reliable when it comes to audit or debugging issues.